And I'm Sheila.
And today we're going to be talking about acids and bases and what pH is. As we said earlier, we're going to be talking about what pH is. pH is on a scale of 0 to 14. And in the middle, pH of 7 is something that's neutral. For example, water. So water is neutral, so it has a pH of 7. Anything that has a pH of 0 to 7 is something that is very acidic. Something acidic is when there's a lot of hydrogen ions in it. And so anything that, usually things you eat that are kind of sour tend to be a little more on the acidic side. On the other side, so a pH of 7 to 14, that's something that's very basic. So they have a lot lower number of hydrogen ions. But the problem with something that's acidic or basic is we can't tell. Many times they have the same color, like water. And so one way we can tell if something is acidic or basic is using an indicator. So today we're going to be doing two different experiments using indicators. And what will happen is when you put something in an indicator, it'll change color. And depending on the color, it'll tell you whether it's acidic, which means pH of 0 to 7, or if it's something basic, so a pH of 7 to 14. So next is an experiment. The first experiment is going to be done by Sheila. And so we'll let her take it over from here.
Hi guys, it's Sheila. So as Ruth said earlier, we're going to be doing the universal pH indicator experiment. In this, we mix with water many different indicators because each type of indicator tells you a range from pH from 0 to 7, or 7 to 8, 8 to 14. It can't do everything. So we put everything in here and it will change color from super basic, purple here, to super acidic. We'll be adding dry ice, which makes CO2 bubbles, or carbon dioxide, which you probably learned in class. As the bubbles come up, it makes the solution more acidic, and it will change color from purple to orange. Now, here's Greg, and he'll walk you guys through the pH experiment.
So what we have here is dry ice, which is frozen carbon dioxide, and we're going to add this to the pH indicator. And carbon dioxide reacts with water to create carbonic acid, which is similar to how our body regulates pH. And the carbon dioxide is going to float up, which is going to change the color of the solution because of the indicators.
Working with cabbage juice. So cabbage juice is really great because it's a natural indicator. It has something called flavin, and that's this molecule inside the cabbage juice that is able to act as a natural indicator. And so once again, as we mentioned before, when you add something acidic or something basic in an indicator, it will change colors. And cabbage juice is able to do the same. So cabbage juice, when it's in an acidic solution, so remember I said in an acidic solution there's a lot higher concentration, or there's a lot more of hydrogen ions, while in a basic solution there's a lot less of it. And so when cabbage juice is in the presence of an acidic solution, what the flavin molecule is going to do is going to be grabbing, or it's going to be stealing a lot of those hydrogen ions, and it'll change colors based on that. While the opposite spectrum is when it's in a basic solution, there's not a lot of hydrogen ions that this flavin molecule in the cabbage juice can actually take. And so because of that, it's also going to be a different color. So next, Sheila and Gray are going to show you actual demonstrations of what happens when you add acidic and basic solutions, or even neutral solutions into cabbage juice.
Hi guys, for our experiment, we'll have 3 different solutions to test. First is a citric acid solution, the second one is a neutral deionized water solution, and the last one is a basic bleach solution. So we'll be adding cabbage juice to each of these. For parents at home, you can make your own cabbage juice by taking cabbages, blending them, draining them, and then keeping the juice after. Okay, so now Gray will guide you guys through
first we're going to add it to the neutral water and see what color it turns.
What color do you guys think it will turn?
Okay, it turned purple because water is neutral, so it didn't donate any hydrogen atoms to the flavin molecule. I'm going to add it to the acidic solution. So it turned red because the acidic solution donated hydrogen atoms to the flavin molecule. So last we're going to add it to the basic solution. Turn yellow. So now that you guys know the ends of the spectrum for acid, neutral, and basic solutions, you can do this on your own by testing different things that you have around your house. Those juices might turn things acidic, while milk could turn things to a basic color.
Now you can test the pH of your solutions at home. First, add a small amount of cabbage juice to 5 cups. In the middle of your 5 cups, you can add water. This will be your neutral. Then you can add your other 4 liquids and arrange them in order of increasing pH. After you feel confident with your order of solutions, you can test the actual pH with the pH strips given to you.
Hi everyone, thanks for joining us today. I hope you guys had a great time watching our chemistry demonstrations on acids and bases and what a pH indicator is. I hope you guys are able to try this at home. You can get cabbages at your local grocery store, and you can find so many of these acids and bases around your house, such as orange juice, shampoo, conditioner. So I recommend that you guys try this at home and try to make even the full rainbow. Remember that chemistry is all around us. It's not just this experiment that we did today. So I hope you guys have a great day, and thanks